Suppose we want to differentiate this function, y equals 3x squared plus 5 all to the power of 100. Now, we learnt in previous videos how to differentiating something of the form ax to the power of n. We saw that its derivative is nax to the power of n minus 1. We also saw that if we have a sum of functions of this form, this thing is called a nomial. If we have several of them added or subtracted, we just differentiate term by term. So for example, if we have the function y equals 3x squared plus 5, we learnt that dy dx is got by differentiating 3x squared to give 6x, differentiating plus 5 is a constant, its derivative is 0. So, if we have more than one term, if we have several terms, we just differentiate each term, and we just use this thing when we're differentiating each term. 5 actually is a constant, and we learnt that the derivative of a constant is 0. Now if you take something like this here, we'd have to expand it out by the binomial theorem. The first term would be 100c 0, and then we take one of these terms, raise it to the power of 100, and put the other term to the power of 0. That's the first term. The second term would be 100c 1 times the first term to the power of 99 times the second term to the power of 1. So we'd decrease the powers of x squared, from 100 down to 99, etc. And we'd increase the powers of 5. We'd have 101 terms. The last term would be 100c 100. 3x squared to the power of 0 times 5 to the power of 100. So you can see that that's not practical. So a very useful way around this is something called a chain rule, where we write our function as y equals u to the power of 100. So we have two terms here, we write them as a single term, u. So we have a single term to the power of 100. If we differentiate this function, it's quite easy. Y is the dependent variable, so the derivative is dy du. Y is the dependent variable, u is the independent variable. So we write the derivative as dy du, and we just have a single term to the power of 100, so we use our rule. We just bring down 100 times u to the power of 100 minus 1, which is 99. So we're just applying the rule that the derivative of x to the power of n is nx to the power of n minus 1, which I proved in an earlier video. So that's dy du. Of course, we don't want dy du, we're looking for dy dx. So the next thing we consider is du dx. So we have that u equals everything inside the bracket. So basically, if you have a bracket made of if you have an expression inside a bracket, try to write it as a single term. It's normally called u. So u is 3x squared plus 5. We can work out du dx. So we differentiate 3x squared, 2 times 3 is 6, we get 6x to the power of 1. When we differentiate 5, we get 0. So we get 6x plus 0, or just 6x. So we have dy du and du dx. Now the way that we get dy dx is to take dy du and to actually multiply it by du dx. These two derivatives are not really fractions, but they actually behave like fractions. So without proving anything, you can just accept it that it's like multiplying two fractions, and we have du above the line and du below the line. So you see we end up with dy over dx, which is what we're looking for. So we know what to do. We've got to multiply dy du, which is this thing, by du dx. So dy du is 100 u to the power of 99 times du dx, which is 6x, and then we can sub back in for u. We said that u is 3x squared plus 5, so we have 100 times 3x squared plus 5 times 6x. And the 6x this is the power of 99. See, we have u to the power of 99. And the 6x is multiplied by 100 to get 600x. So we have 600x into 3x squared plus 5 to the power of 99. So here I've applied the chain rule to what is essentially a polynomial. If we were to expand this out by the binomial theorem, we'd have a polynomial. We'd have several nomials. But in later videos I'll apply the chain rule when we're differentiating trigonometric functions and exponential functions. By the way, you won't have to go writing out dy du and du dx from now on. All you've got to do is is follow this pattern. So our function is y equals 3x squared plus 5 to the power of 100, and we want to get dy dx. So without explicitly writing down what u is, and writing down y as a function of u and u as a function of x, and getting dy du and du dx, all you've got to do is remember the following. What we do is, when we have something in brackets raised to a power, we start by bringing that power down in front of the brackets, taking 1 from the power, and then multiplying by the derivative of what's inside the bracket. So we differentiate what's inside the bracket. The derivative of 3x squared plus 5 with respect to x is 6x. And of course we get 600x. We multiply the 6x by the 100. So we get 600x by 3x squared plus 5 to the power of 99. Of course we do not multiply 600x into this bracket here. If we wanted to expand this out more fully, we'd have to raise 3x squared plus 5 to the power of 99, which we don't do, of course, and then multiply by 600x. So just to explain this again, we just differentiate around the brackets. So we bring the 100 down, take 1 from 100 to get 99, and then we multiply by the derivative of what's inside the brackets. The derivative of 3x squared plus 5 with respect to x to give 6x.